All right, hello and welcome to 3.2. This is Postulates and Theorems about angle pairs. Again, I'm sorry for 3.2 starting at the bottom of the page. Now I want to start out with this little, kind of like an exercise, if you will. I'm going to zoom out for a second. So, we have this shape here, okay? And so what it's asking is it wants us to estimate angle 1. Let's take a guess, right? So, it's not quite a 90-degree angle, as you can see. So let's call it like 80. Why not? Roughly 80 degrees, right? It's almost 90, but not quite, okay? So we want to place angle 2 on here. Let's write a 2 on here so it's corresponding. Remember, corresponding is on the same side as the transversal, so on the top. Again, this is the transversal. And then on the same side of the line, so on the right side. So top, right side, so it has to go right here. Now the question is, what does angle 2 look like? Now, it's quite a bit bigger than angle 1, right? Quite a bit bigger. 110-ish. Okay? Are those two the same? So even if my estimations were bad, right? Do 1 and 2 look like the same size of angle? Absolutely not. Okay? No. So the question I want you to think about, which is probably not going to get you there right now, but is what needs to change in this picture? How would you, if you could take that and move them around, what would need to change so that 1 and 2 are the same? Okay? That's what I want you to be thinking about right now. Try to develop an answer. I want you to write your answer right here in these little quotes. Okay? Write your answer in here. Okay, scribbles. I can't guess what you're going to write because I know the right answer and my brain is tainted, but you can guess, okay? So write something in there for me. Make sure you can try to figure it out. What needs to change here that makes those actually be the same angle, okay? All right, so let's get started on some postulates, okay? So the first one's going to be a postulate. The next 3 are going to be theorems. And that's really not for any good reason. Again, postulates we're going to accept without proof, and theorems is something we could prove if we had the time. Now, you can take actually any of these as postulates and use the rest as theorems because they all build off each other. But the first one's probably the one that is most commonly used as a postulate. So it's going to be the corresponding angles theorem is the name of it. Corresponding angles. We'll call it postulate here for this class. Okay, that's the name of it. Now it says, if 2 lines are parallel, P and Q, and are cut by a transversal, T, then the corresponding angles in the picture are congruent. Okay? So that's really important because in the last section we had corresponding angles. We talked about what they look like. We said this one and this one are corresponding, this one and this one, this one and this one, this one and this one, right? There's 4 pairs. We've talked about corresponding angles, but they had no relationship. But now they're congruent. Okay? As long as P and Q are parallel, which they are by this little tick mark, right? If these 2 lines are parallel, then corresponding angles are congruent. Okay? So that's the big thing here. They are congruent. Okay? Now most of these are going to be congruent, but that's the big change here. The big change is that these lines have to be parallel. Okay? Really, really important for this section. Okay? The second one, what's this angle pair? Well, they are alternate interior angles. So the alternate interior angle theorem. Okay? If these 2 lines are parallel and cut by transversal, then these are congruent angles. Okay? So again, these are congruent. Now, just to if you're just here not to get the proof or anything, that's fine. But here's how you prove this, right? If we take this one as gospel here, and we believe this, and this is something that we can use, then here we know that 4 and this angle down here are congruent, right? Because we know from up here that the corresponding angles are congruent, and corresponding to 4 is this one right here, right? But these 2 angles have a relationship, and they're vertical, and they're the same. So if these 2 are the same, then these 2 are the same, and if those 2 pairs happen, then 5 and 4 are the same. That's the mental proof, right? Pretty easy, and they're all that easy. So if we were in class, we could prove those like nothing, okay? So that's why they're theorems, okay? Or else I just call them postulates. All right, next one. 2 lines are parallel again. If these are parallel, then we have the AEA theorem. Okay, again, these are congruent. If these are alternate exterior angles and these are parallel, then they are congruent. Okay, and now we have the odd one out. This is the same side or consecutive interior angle or same side interior angle theorem. Okay. If the 2 lines are parallel and we have the consecutive interior angles or same side interior angles, then they are supplementary. Okay? Again, these make 180 together. Okay? That's their relationship. And that's all the new stuff this section, right? We're going to look at angle pairs and we're going to say, hey, these two are corresponding, so they're congruent. Okay? So we can really, the goal of this is that if I give you one angle, if I give you angle 2 in this picture, I want you to be able to tell me every single angle across the entire thing. That's kind of the goal of this section. All right? So, here we are. We have number 1. If the measure of angle 3 is 42, find all the other measures in the diagram. So 3 is 42 degrees. Now, you have a bunch of options, okay? So let's go ahead and write our measures out. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4, measure of angle 5, measure of angle 6, measure of angle 7, and measure of angle 8. We know 3 is 42 degrees. Okay? Now, I will never tell you that there's one way to do this. You can jump around to a bunch of ways. So what I'm going to do is I'm going to instead tell you how I would do it, and then you can go ahead and do it your way. So this is how we're going to do it here. It's not how I personally would do it. You'll find the easiest way. I believe in you. I'm going to use at least one of all 6 options. Okay? So I'm going to put in orange the way that I did that for that one. Okay? So to start with, 3 and 1 are the same. They are the same because 3 and 1 are vertical angles. So that means that 1 is 42 degrees. And I used vertical angles here. Okay? Now, 2. 3 and 2, they are a linear pair, which means they make 180, right? So this would be 138, right? 180 minus 42. Okay? So this one's 138. I use the fact that they're a linear pair. Okay. Measure of angle 4, we'll come back to that. I'm going to use the same one as before. Okay? Measure of angle 5. Now, we have a bunch of options. Let's go ahead and use corresponding. Let's get corresponding out of there. So 5 is corresponding with 1. So that means that 5 and 1 are congruent because these lines are parallel. And so 5 must be 42 degrees. And I used corresponding there. Okay. This is 42. 6, well, let's use same side interior. So 42, so angle 3 and angle 6 are same side interior. So if this is 42, then this must be 138, right? Because those are supplementary angles. Same side interior. Now, obviously, you could also use corresponding with 2, right? You get 138 because those are congruent. This is where you have a bunch of options. I'm going to use all 6. You don't have to. Okay? Now, 7, we should use alternate interior. So we should use 7 and 1, or alternate exterior, excuse me. So that would be 42 degrees. Alternate exterior angles, 42. Let's go back to 4. We should use alternate interior, so 4 and 6 are the same. So this is 138. 138, alternate interior angles. And now we can do whatever we want. I don't know why I started using black there. Okay, for 8, let's just use the fact that 6 and 8 are the same, right? They're vertical. So 8 would be 138. Again, we used vertical here. Okay, and you have a bunch of options. Now, you'll probably figure it out faster than I can tell you. There's an easiest way to do this. But you can do whatever way you see. If you see an angle pair that works out, use it. Okay? But we'll be practicing these quite a bit. This will be something that you'll get very good at. All right? On to example 2. Find the value of x and explain why we could set up that equation that we use. So what angle pair gave us that? So first off, here we have a transversal and 2 lines. Okay? We are given that the lines are parallel. So let's go ahead and mark that. Little arrows there. Now we know they're parallel lines. Now, by the theorems from this section, look at the relationship. You should be pros at this point, right? You should be instantly knowing that those are alternate exterior angles. Okay? So, alternate exterior angle, I'm going to write that right here. And we know from this section that alternate exterior angles are congruent. And so we can write 113 equals 3x minus 4. Go ahead and solve it. 3x equals 117. I have no idea what that number is. Do I even have a calculator out? I don't. Found it. 117 divided by 3. 39. Okay, so x is 39. The reason is the alternate exterior angle theorem. Okay, we know that alternate exterior angles are congruent. That's it. Okay, part B. Here we have a couple of different things. This is a tough one. Okay, so that T and F, or T and R, are parallel. Go ahead and mark that. Okay, T is not the transversal here. That's trying to trick you. Now, what you should be thinking is that these two angles have nothing in common. Okay, that's the thing. They have nothing. There's no relationship, right? But we can use the other angles. Remember, if we have just one of these angles, we can find all of them. We can use this in order to solve it. So you can really use whatever one you think of. What I would say is that I know that x plus 5 and whatever this angle is right here are the same. Those are corresponding angles. So I can put x plus 5 right here. I'm allowed to do that. I'm allowed to do that because of the corresponding angles theorem. Forgot the A. I spelled it completely wrong. Angles theorem. Okay? If these two lines are parallel, then these two are the same. But now, these two are a linear pair. And I know that linear pairs add up to 180. So I can go 3x minus 7 plus x plus 5 equals 180. And I can solve this. Combine like terms, add, and divide by 4. 45.5. Makes you think I messed up on the algebra there, but maybe not. Okay? So 45.5 is our x value. Nothing crazy. Okay? These are tricky because, there's 6 options of what you could have done first. Okay? Just choose one that looks good to you. Make sure you document the reason that you used, and that's good to go. Okay? Putting the reasons down should feel more natural now that we did the proof unit, right? It should feel right that we're saying, hey, here's why I did this. Here's how I knew it. All right? On to the last section, or last problem. We're going to prove something. So it says, prove the theorem that says, if two lines are parallel and cut by a transversal, then the alternate interior angles are congruent. So this is what we're going to do. We have the postulate, right? Like I said, we have this first one. Okay? And so what we're really doing is we're really proving this one. Now, I kind of spoke it out loud, right? But we should prove all of these, and I'm only going to prove this one. And the reason is that they're all very easy. Okay? We're going to use the corresponding angles postulate in this, but other than that, they're not hard to do, and so we're not going to do them all. Okay? I'm just going to prove this one. If you want to see the rest of them, let me know. I'll do them for you. Okay? But let's go through it. So we are given that we have two alternate interior angles. So let's say angle 1 and angle 3, or angle 2, are alternate interior angles. And of course, we need to know that P is parallel to line Q. Okay? These have to be parallel for this to work at all. So those two things have to be given. And we need to prove that angle 1 is congruent to angle 2. Okay? Nothing crazy. So, we have our reason, our statements, and of course our reasons. Just like last chapter. Okay? Start with the given. Angle 1 and angle 2 are alternate interior angles. And line P is parallel to line Q. Those are both given. I'm actually going to put a little line. Okay, that's the first one. So that's the given. What does that tell us? Okay? Now, from this picture, we have that 1 and 3 are congruent. Okay? They're congruent because of the corresponding angles postulate. So, angle 1 is congruent to angle 3 by the corresponding angles postulate. That's the postulate from this section. Okay, we needed one of them, right? So let's wiggle on. So now we have 1 and 3 are the same. Now remember, 2 and 3 now are the same. So angle 3 is congruent to angle 2. Why? Well, those are vertical angles. And vertical angles are always congruent. Okay, we've learned that in the last chapter. And now we're on to the last step. If 1 is congruent to 3 and 3 is congruent to 2, then angle 1 is congruent to angle 2 by the transitive property. Property of congruence. Okay? Remember, A equals B and B equals C, so A equals C. It's an exact transitive setup. Okay? And that's it. It's that easy. 4 steps. Okay? Nothing to it. So now we have actually proven that alternate interior angles are congruent given that these lines are parallel. Okay? Nothing too crazy. Definitely doable. Maybe I'll put one of these as an extra credit on the test. Prove that, you know, alternate exterior angles are congruent. It's going to work the same. Okay? Well, thanks for watching. Good luck with your homework, and that's all I got for today.